Welcome to our MOOC Technical Drawing for Mechanical Engineering. Welcome to our Module 2 of MOOC. Module 2, we are going to talk about frequently used standardized parts. This Module 2 will be divided in 3 units. Unit 1, we will talk about bolts, screws, pins. Unit 2, bearings and circlips. And Unit 3, gears. So let's start with Module 2, Unit 1. In this Unit 1, we are going to talk about bolts, screws, and pins. Before we start, why are standard parts important? Because they have standard dimensions. These dimensions determine certain dimensions in other parts of the assembly, and the standard designation will be in the title block. Sometimes we will use ISO standards, and sometimes we will use European DIN standards. It depends. Bolts. A bolt is for assembly of two parts which have no female thread. A bolt is a pair of thread and of male and female thread. We could say it is formed by a screw and a nut. We have here an example of a bolt. It has a screw and a nut. We can see it clearly in our exploded view. The bolt assembles these two parts you can see. Neither of both parts has a female thread. Both of them just have a through hole. Here we have our assembly, but these through holes can't have any diameter. The diameter depends on the bolt thread nominal diameter. Here we have our title block. We have here the two parts assembled by the bolt, and we have here the standard for the nut and screw. We have here a detail of our bolt and the two parts, the cover and the fixer, which will have the holes. Here we have the plane for both parts. The screw is metric 10, so the through holes must have 11 millimeters. It is also important to see that this dimension must be the same in order to be able to assemble both parts with the bolt. Screws. The two most common types of screws are the countersunk screws and socket head cap screws. The screws hold two parts together, but one of them has a blind female thread, and the other part needs a countersink. The dimensions of this countersink depend on the screw standard and its thread. The dimensions of this countersink must be given in the part plane. As you can see, the head of the screw will be hidden inside the countersink. You can see disassembled countersunk screws. As you can see, there are 4 countersinks. So part number 2 and part number 1 must have 4 blind threaded holes. In this case, for the screw with thread M10 and DIN 963, these are the dimensions for the countersink, which you can see there in the part plane, in the cover. Same things happen with the socket head cap screws. One of the two parts must have a counter bore. and the dimensions of the counter bore depend on the thread and the standard. So in this case, these are the dimensions for the counter bore. Pins. Pins are used for fastening parts together. Here you can see a simple cylindrical pin, and there is a kind of pin, the split pin, which is frequently used with a nut to avoid it to unscrew. The standard for cylindrical pins is ISO 2338. Our effect clamp has 3 pins. You can see them here in detail. The first one, this pin fastens the adjustable screw and the head. This pin prevents the bar from going through the movable jaw. And finally, this pin fastens the handle with the adjustable screw. So each pin has a different function, although they are equal. The dimensions of the pin determines the dimensions in some parts of the assembly. This is a designation in the title block. The pin diameter is 2 millimeters. So we can see here the hole in the head, 2 millimeters diameter. We can see here the hole in the handle, 2 millimeters again. And we can see here in the bar 2 millimeters. See the adjustable screw. This dimension is 2. You can see it red on your right. But see the difference. In this case, it hasn't got a hole. It has a toroidal groove. Why? This is very important. If we do just a hole, it won't be able to rotate. We need it to rotate without the pin rotating. So we need a toroidal groove. Split pins. This is how the split is assembled. The 2 tines are bent during installation. The dimensions are in standard 1, 2, 3, 4. We have here the pin, and the section is a circle, so the part where it is assembled must have a through hole. The dimensions for this through hole are in the standard. Here we have a split pin in our jack screw. We can see it in different projections. So you will see them represented in different points of view. Of course, it is easy to recognize it in the left view. See here the designation. The pin diameter is 4 millimeters. Its length is 20 millimeters. The hole in part 7 must be 4.5 millimeters. See now the threaded rod. It has the hole for the split pin. So this is the end of Unit 1 in Module 2. As usual, in our summary, what have we learned? A bolt is a pair of screw, male thread, and nut, female thread. The assembled parts must have a through hole. The diameter of the through hole depends on the nominal diameter of bolt thread. There are many types of screws. The screws hold two parts together. One of them has a hole, counterbore or countersink, depending whether it's a countersunk screw or a socket head cap screw. You can see here both types. Here we have a split pin and a cylindrical pin. They fasten two parts together, so the parts must have a hole or a groove, as we have seen in the clamp. The dimensions of both of them depend on the pin. So after a summary, we will be waiting for you in Unit 2.